Hello everyone, I am Mamumino Kamo. Nice to meet you all. Today, we'll be installing an AI video generation software on my computer. Amazingly, this AI generator can be used for free and works right in your browser. It's called Pyramid Flow, and we'll be following the instructions on this GitHub page. Well, it probably requires at least 16 gigabytes of GPU memory. I'm going to daringly try it on a computer with just 8 GB. Well then, shall we get started?
Hello there. This really feels like a video version of Stable Diffusion. Wow, we're now in an era where we can create videos with open source software.
Hello, Takayama-san. Yes, that's exactly right. The actual screen will come up soon, so please wait a moment.
By the way, what do we need to run Pyramid Flow?
Right, I should mention that, or viewers might have trouble. For those using Windows, which is the most common, you'll need several things for the video. Particularly regarding the Python version, let's use the one recommended on GitHub. Alright, preparations are complete. First, we will copy the project to our computer. I'm working on Windows right now, but you can do this on Linux too. Of course, it also works on Windows WSL. Now, let me check the Python version that's installed on this computer.
Oh, this is different from the recommended version. Shall we use our usual method here?
Yes, we will use PyEnv to use the recommended Python version just for this directory. For that, we will use the PyEnv commando install the recommended version. This way, we can switch between different Python versions depending on the project. Regarding PyEnv installation, I have made a video about it before, so please check that out for reference.
Being able to manage multiple Python versions without affecting other projects is really reassuring.
Yes, and since it doesn't depend on the system Python, it's great that we can avoid troubles posed by upgrades. And what's important here is that while we are in the Pyramid Flow directory, we need to set it to use the specific Python version. Now, let's verify if we can use its specified Python version in this directory. Ha! That's strange. It's still using the system Python.
Here comes our usual trouble. So what do we do from here?
Geez, you are such a noisy old man. I really have no idea what's going on here. Well, I guess let's check what's inside this directory first.
Alright, when things get confusing like this, let's just restart VS Code first.
Yes, I got flustered by the old man's comments. As Takayama-san suggested, I have restarted everything. Oh, I forgot to check an important file. Let me take a look at what's inside this file right away.
Congratulations! It's now using the specified version. We restarted everything, so it should be good to go.
Thank you. Let me check the Python version one more time. Yes, I think this was resolved by the restart. Now, let's create and activate a Python virtual environment.
The official GitHub page used conda commands, but I see we can do it this way too.
Yes, while you can easily create a virtual environment using the conda create command, this time we are using a Python virtual environment. Since we might use conda in the future, I have put it in a table. Everyone, this is where you'd want to take a screenshot. Just kidding. Now that we have got our virtual environment set up, shall we install the necessary packages? This command is used to install all the Python packages the project creator determined were necessary, all at once. Please wait a moment. Whoops! We have got a warning message here. Since I'm familiar with this warning message, I will explain it later and continue for now. There's a script in the project, so let's run it.
Oh and no, this looks like it's trying to run on CPU only.
You noticed that too? Let me explain this in detail. In many projects, as shown here, they list the CPU version of PyTorch in requirements.txt, making it possible to run even in environments without CUDA. However, take a look at this requirements.txt. You can see it includes CUDA specifications, right?
Oh, you're right. That's very thoughtful of them. So this project doesn't include those specifications.
But users might not necessarily use this version of CUDA, right? Wouldn't that cause problems in those cases?
Ah, I see what you're getting at. So basically, this project is telling us to install CUDA manually.
Yes, that's exactly what I think. Well, if they meant it only works with this specific CUDA version, they could have included that in the requirements. Let me summarize what we have covered so far. While what's shown in the video is important, I really feel that carefully reading the official documentation is crucial. Next, since it seems we were missing some packages earlier, let's address that. Actually, there is an equivalent command to using requirements text, so let's try that one out as a learning opportunity.
Interesting. I didn't know about that command. It's always good to try new things, isn't it? Please explain it to us. It'll be a good learning experience.
Yes, and I will clarify the difference. The differences are like this. This might be useful when you want to do a temporary installation check if things work properly. I see we are getting some messages about PIT. Let's upgrade it to the latest version. Well, I was thinking about that, but I have decided to use requirements text after all. Why? Now we can finally run the script.
Wait, aren't you forgetting to install CUDA manually?
Actually, that alternative command we tried earlier might have installed the CUDA-compatible version of PyTorch.
Oh look, you're right, the script is running normally. However, this is quite a large model, and the file size is huge too.
Yes, this looks like it's gonna take a while, so I will definitely skip this part. Finally, we are ready to create videos. Shall we check it by accessing it through the browser? Ideally, we should access it from another computer. But let's continue with this setup for now.
This is wonderful. Could you create something for us? I'm worried about insufficient GPU memory.
I understand. Let's try to create a video from a single image. Like with Stable Diffusion, where we could create images from images. I am a bit concerned, but let's see if we can generate a video. It seems we can enter a prompt to specify what we want to do with this image, but this time let's try it without entering anything.
Surely after coming this far, we won't fail to create a video, right?
Hey, old man, just watch quietly for a bit. Look, it's starting to move. What? An error? This doesn't look good. It's too early to give up. For now, let's try using a sample. Come on, move, please move. This isn't working. Let me review the settings.
Let's take a step back and calm down. It seemed to be working normally, but something's wrong. This is quite troublesome.
Yes. However, I have some ideas about what might be wrong, so I'll investigate those areas. First of all, we need to check the CUDA version on this computer. We can confirm it's version 12.4. So, we need to install the version of PyTorch that's compatible with CUDA 12.4. The command is clearly written on the official website. So, we can just copy and paste it.
Good work. Now we just need to run the script and start fresh. Let's hope it works this time.
Yes, that's right. It's rare for things to work perfectly on the first try anyway. This time, I will test it using a sample, just to be safe. All said, I will click the Generate Video button. As shown in the video, this is the mode for creating videos from text.
Oh, this time we're not getting those previous errors. This looks promising.
However, since it's video, it seems like it's going to take quite a while. Yes, the video is now complete. This prompt was meant to show a snow-covered Tokyo street scene, but this is how it turned out. We were supposed to create a video like the one on the left.
This definitely doesn't look like a Tokyo street scene. Is the video generation problem due to insufficient GPU memory?
I think that's probably the case. However, I do have a video that we managed to create, so I will show you that. But first, as a learning exercise, let's create a script to display the GPU capacity. This will serve as evidence that we could create something even with this GPU size. I can confirm it's 8 GB. This is actually my highest spec computer too. Hey NVIDIA CO, how about sharing about 100 GB of GPU memory with me? Don't be so stingy.
Are you crazy? They won't just give it away for free, don't embarrass us Japanese.
But hey, maybe they will give it to me if they watch this video. Just kidding. Alright, let's continue. As for the generated video, it seems to be saved in a directory within the project. While the quality is certainly lower than the official examples, I think it turned out reasonably well. So that's my introduction to this video generating AI. Everyone, let's meet again next time. Goodbye.